Today we're going to look at negative exponents. Now before we look at some examples, let's look at some examples using positive exponents that we're familiar with. So 3 squared is going to look like 3 times 3, which is going to give us 9. And we can say 2 to the third power looks like this, which gives us 8. 2 times 2 times 2 gives us 8. Now, what if we were given fraction forms of these? So it really doesn't change a whole lot other than the fact that your number is just going to continue to get a little smaller depending on how big that exponent is. Okay? So you can have or express your exponents in the denominator, okay, as long as they're positive, and really your number will just continue to get smaller and smaller. Okay, now let's look at this. Let's clear this. Let's get rid of this. Okay, and now let's look at some examples where your exponents are negative. And what are we going to do? Okay, let's have a look. So there's a little definition of what we're looking at. Power, basically it has, if it has a negative exponent, then it has no meaning expressed that way. Okay, so in order for us to find meaning and to simplify, what we need to do is change the exponent from negative to positive. So let's look at this example, 3 to the minus 4. So as we just stated, we can't expand or simplify this the way it's written, but here's what we're going to do. We're going to write the term under 1 and change the sign of the exponent. So it's going to look like this, 3 to the 4th power. So we would say these are equivalent terms. We can't simplify this one, but we can simplify this one. And of course, 3 to the 4th power is going to give us 81, 1 over 81. Okay, now let's look at this one here. 2 to the minus, let's say minus 5th power. Again, expressed with your exponent is expressed with a negative, so we're going to take that and put it under 1. Okay, we are doing or showing the reciprocal of the way it's expressed here. These are over 1, so the reciprocal means we just kind of turn them over. Okay, the numerator becomes the denominator, and the denominator becomes the numerator. And when we expand, this is what we end up with. So this looks like 1 over 32. Okay, now, what do we do if your exponent, let's change this. So if your exponent is in the denominator and it's negative, okay, so here's what we're talking about. So if you have something like this, 1 over 2 to the minus 3. Okay, so how are we going to simplify this guy? So we're going to follow the same thing, the same theory that we used in the above examples. We're going to show the reciprocal and change the exponent from negative to positive. But instead of putting this, it's already under 1, we're going to put this over 1. So when we show the reciprocal this time, the 2, and we're going to make this positive. Now, I'm just going to do it this time just to show you the first time, but I wouldn't express it over the 1 each time. If it was me, there's what you're going to show. Okay, 2 to the 3rd power, just to show you that it is the reciprocal. To put it over 1 you can, but I wouldn't do it each time. You're just making extra work for yourself. And then of course it's positive, so you can simplify it and get yourself an answer. Okay, now let's do one more quick example. And where can I sneak this? We'll sneak it, we'll put it right here. 1 over, let's say, 4 to the minus 2. So again, if I was going to express that, I would say, okay, there it is, 4 squared, and that gives us an answer of 16. Okay, now, if you've got something that looks a little more complicated, so let's just change colors here so we can see something different going on. So if you had something like this, let's go 3 to the 4th power times 6 to the minus 5th power, And we have 5 to the minus 2 times, this is an exponent, 7 to the third power. Okay? Actually, I'm going to fix that. I don't like the way that looks. There, just, and this becomes minus 2. Okay, sorry about that. Now, rule doesn't change. The 3 to the fourth power is fine. We're going to leave that. But this 6 to the minus 5, we're going to take this term and we're going to put it under 1. Okay? And we're going to take this 5 to the minus 2, and when we do the reciprocal, it's going to go over 1. So it's going to look like this. This becomes 5 squared, and the 6 to the minus 5th is going to become 6 to the 5th, and of course we don't touch the 7 cubed. Now, so in conclusion, we can express this a to the minus n equals 1 over a to the n, and a cannot be equal to 0. Okay, so I hope this helps. Good luck.